Hello, hi guys. Hello, a very good evening. Uh, Hello, can I have a response from you all in the chat? Hi, this is Nidhi from Let's Upgrade. Can I have an introduction from all of yours, like from where you are now joining, what you are doing? So you are a working professional or student? Hey, hi everyone. Hi. Good evening. Okay, so it's great to see that we are having students and working professionals joining from different places. Okay, hi. Fine. I hope I'm audible to all of you. Nidhi, hi Nidhi. I'm also Nidhi. Yeah. Okay, I'm good. Great. So, great guys. So I welcome you all for machine learning day one. I'm here just to give you all. I'm not your trainer, first of all. I work in LetsUpgrade, and I'm here actually to just give you and tell you the flow of the program. So how you will be eligible to get the certificate, and what are the steps you have to follow, and all everything. So the very first thing is uh, you have to go and get registered yourself for the program. Okay. So unless or until you have not registered on our website, you won't be, and then you come here and fill the attendance. You will not get your certificate. So the very first step which you have to do is go and register. I think the link is there in the description, and I'll ask the mod also, please share the link so who are the students are directly coming on YouTube live and have not registered for the program, they can register themselves. Shubham Kumar, this is a 3 days program, so you will, as it will be mentioned on our website as well. Okay, so attendance link and everything will be given here. And what you have to do, you have to come live for all the 3 days. You have to put your attendance for all the 3 days. If you miss even one day, you will be not getting your certificate. So I hope this is clear to all of you. Even after attending all the 3 days, putting your attendance, but you have not registered for the program on Let's Upgrade website, you will not get your certificate. So these 3 points, you just make it very clear. Okay, go register yourself, put your attendance for all the 3 days, and the very last thing is you have to submit your attendance with the email ID which you have registered on Let's Upgrade. website. Okay. So these are the three things. Okay. Hi, hi, hi. Hi, everyone. So other than this, if you have any questions for me, you want to ask anything, you want to know anything, just put it in the chat. I will be answering all. If not, then we can start the session. Your trainer is here, so we can start. If you it showed already enrolled. Adil, you would have already enrolled for the program. That's why. So there is no issue for you. Just that while putting the attendance, make sure you put the registered email ID only. Okay. Sagar, class timing is, I guess it's 9:30 to 10:30. Here, there, I'm a working professional with a commerce background and wanted to know where there will be any workshop or business analysis. Priyanshu, sure, we will be coming up something with related to business analysis very soon. As of now, nothing like that has been scheduled, but very soon we will come with that also. Where we update the attendance, Vicky, you will get the attendance link in your description, as well as the mod will put that into the chat also. So you have to just keep watching and fill it. Zuhair Ahmed, I am already registered. If you have already registered, no issues. But if you have not registered, guys, just make sure go and register yourself, because unless or until you are not registered, you won't be getting your completion certificate or any certificate. Is this certified learning? Yes, it is certified learning. If the class will be conducted by only in night, yes, the session timing are 9:30 to 10:30. Other than that, guys, if you have any questions, just put it in the chat. Okay, so I think you all are done. Let's start the session. I'll welcome your trainer. Yeah, all
Hey,
right.
what's
So
up?
Gopal sir is
So sorry for
there.
being
Hi.
late.
So
Okay,
he
firstly,
is a very good
and
trainer, and he train our students also. Yeah. Other than that, whatever is there, sir will introduce himself, and he will tell what and all he is going to teach.
hey,
So
Subhashis. Hey,
sir,
Yogesh.
you can start. Thank you.
Thank you. Okay, thank you. Hello, everyone. My name is Gopal Singh. Okay, as you can read, or I think I'm not on. Okay, okay. Hello, everyone. My name is Gopal, and you can I'll be your trainer for the next 3 days for machine learning essentials. Okay, and for zero to hero. Hey, Gopal, bro. Hey, Nayab. Hey, Biresh. How many of you have taken my previous sessions here? Like maybe for data analysis, maybe for Python, maybe for machine learning itself. Like how many of you have taken my previous sessions here? Just let me know. Anyone? Hello, Ishwar. So I just want to update my email. Then do it, dude. Okay, then do it. All right. And how many? How many? How many? Misa data. Oh, Jivita. Hey, first time. First time. Okay. All right. Hey, where are you from, guys? By the way, data analytics. Okay, great. So like I can see a few people, maybe like two or three, like they have taken my sessions, maybe for the data analytics, right? From West Bengal, Chennai, Hyderabad. So how many of you have right now like totally in a free mood to have a good sessions, like a session about the machine learning? Okay, we will be just talking about like in general machine learning, not so much coding stuff, not so much technical stuff, but a real scenario like where we can make some sense out of it. Attendance कैसे लगेगी? I think that can be answered by the moderator. Okay, so okay, all right, great. Like we have a lot of here janta here who is waiting for this session to start. So I'm not gonna bore them up with my introduction or anything. Okay, so let's get started already. But ना क्या बात है भाई? ठीक है. So how many of you can speak Hindi here? How many of you understand Hindi here? Everyone understand Hindi here? Everyone, just let me know. नो, यस 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 यस। ओह ग्रेट। मशीन लर्निंग के लिए कौन सा सॉफ्टवेयर यूज होता है, अभी बताते हैं सर सब कुछ। हिंदी लिटिल बिट ओके, डोंट वरी, आई विल बी स्पीकिंग इन हिंदी, सॉरी नॉट इन हिंदी बट इन इंग्लिश, ओके। एंड या, बट आई डोंट नो व्हाई आई एम नॉट बीइंग एबल टू शेयर माय स्क्रीन हियर। लेट मी डू दैट अगेन। आई डिड दैट बट आई डोंट नो। ओह, ओके, I'm not being able to share my screen, Nidhi. What is happening? Just a sec, guys. Like, I think. Mhm. Okay, let me try this again. Chrome tab. Okay, window. All right, share this. What the hell? Why am I not being able to share the screen? Moderator, I'm not being able to share the screen here. I don't know why, but it is like I cannot share my screen here.
Good evening, guys. Guys, just please wait for some time. Sir is facing some issues. By the time, guys, whatever doubts you have, please text us in the YouTube chat box.
Okay. Oh yeah. Okay. Okay. Great. So I guess now everyone can see my screen now. Okay. So now let's get started with our very first, day for machine learning essentials. Okay. So what exactly machine learning is? So how many of you have heard about it? Obviously, like it's a boom here right now, like especially everywhere in the world. But what exactly the machine learning is in the first place? Okay. What exactly the machine learning is? Okay. When we talk about like when we see, sir, I think you are a gym lover. Maybe. I'm not a gym lover. I'm a football lover. I love like being into fitness and like I just love into that. Okay. So I'm not a gym lover though. Hello. Okay. So what exactly the machine learning is? So let's actually talk about this. So for me, machine learning is the ability to extract data and make some sense out of it, and drawing some patterns out of it. For example, let's say you are planning to buy a house in your neighborhood. Okay, and you want to know like what would be the price. You can actually predict from your understanding, like the square foot of that house, or maybe the age of that house, like those parameters, and based on that you will going to try to predict the price, based on these parameters or based on these features, right? So this will just going to bring out the price, right? Okay, so for me machine learning is a process of extracting data, making some sense out of it, and drawing conclusions, or giving up some, not giving up, but outputting some results out of it, right? Based on the model. Okay. So we will going to understand, like, like from each one of these. And first I would like to show you, like, the slide which I have prepared for you. Okay, so let me just bring this up here. Okay, or keys. Okay, there you go. So sorry, like I'm calling you right here. Look, okay, but yeah, it will just gonna make sense. Okay. So machine learning for rookies. What exactly, like, why exactly I gave it this, this title to this slide? So you're gonna get an understanding about, But the problem here is, like, why do we need machine learning in the first place? And what is the, like, what is the need for it? And why exactly it is booming right now in the software industry? So even before coming to that, like, let's consider a scenario, like, why do we need machine learning? So consider the following scenario where you have been asked to write a spam filter. So, like, spam filter is one of those, the most, like the oldest one, machine learning's implementation, where we implemented a spam filter to determine, like, if an email is spam or not a spam. Okay, so how exactly we did that? So if we go with the, like, if we go with our traditional programming approach, how exactly it will gonna look like? So let's say, like, your email has what? Like, you have subject, right? You have a subject and a body, right? Let's actually, for now, forget about, like, from and everything. Let's actually not, talk about this. Let's say, like, you have only two things here. The first one is your subject, okay, and the second one is your body. Okay, and for the subject you can have what, like, from, like, let's say, from XYZ person. Let's call it a from XYZ person. Okay, and for the body, let's call it, like, like, the body could be something like this. Okay, this email was sent from XYZ person, right? Let's say, like, this is your body. Now we have to create, like, we want to create a system which can determine, like, if this email is a spam or not a spam. Like, let's actually call it a system. Okay, we will gonna get into it, like, what exactly the system is all about. Okay, so this will be your spam and not a spam. Spam and not spam. Okay, so how exactly we are going to determine it? Let's see. So, like, after that, like, let's say after a while, you tend to determine, like, these are, like, your words, like, free, for you. You actually found these words in your subject. Like, these words, like, in your subject, like that. Let's say, like, you in your subject you have these words, uh, like this. Like this, free $5 million. Okay, from Nigerian prince, right? From Nigerian prince. Like, I hope you may have received this, like, maybe once or twice, but let's call it, from Nigerian prince. Okay, and apparently, Nigerian prince, being so humble, he also gave you, like, all credentials, like, how exactly you can approach him. All you just need to do, you just need to enter your, bank details. The dude is totally humble and, like, genuine. All he is asking for account number of yours, or maybe more details about it. Okay, so what you do, like, okay, like, if you are not so much familiar with the Nigerian prince, you might want to give it, away, like, you might give your account number here, maybe IFSC code as well. Okay, all right. And in that case, I don't know, like, if you will going to receive 5 million or not, but definitely, like, there will be no penny in your account. Okay, so in that case, what I can determine, like, this subject, like, this word free, this word 5 million, or from, maybe, like, Nigerian prince, I will gonna flag these words. How exactly I can flag? Like, let me actually make a, list here. Flag words. Okay, and I can make a list here. You know what? Like, free, or maybe U, capital U, or maybe, prince, something like that, or maybe dollars. Okay, if I found any words, from these flag words, okay, then I'll going to determine, I'll going to declare that email as spam. All right, okay. So now, now in this case, like, okay, you might think, okay, like you may have actually come up with a solution, like which is, like this subject. Okay, but what if that dude is somewhat more shrewd than you can ever than you can think, and like maybe you can flag these words for you, and free. But what if we come up with new words like this, free and you? Then how many words you will going to flag? Like the possibility here is innumerable, right? You cannot, you just cannot go and start flagging each word there. So okay, so that's where your machine learning actually comes in. How exactly? So what you say, like, okay, let these let these subjects and like these text of body's text, let me actually handle this with the help of linear algebra. How exactly? Let's see. Let's see. Okay, so I will be okay. So what if we can actually approach this like in this way? Okay, like this case is your like flagged, or like I would say spam. This case is for the spam, and this is for not spam. Okay, so what if I can somehow come up with this line, okay, this line which can separate my not spam to spam. Or whenever I project a new data here, like here, I can just determine like if it should reside here or here. That is where your machine learning actually comes in. Okay, so like if we go back to our very definition, the very first definition of machine learning. So when an algorithm learns from the data, okay, and you come up with a mathematical function such as y, not always, of course, not always, y is equals to fx, right? So where x is a feature vector. Let me explain what exactly the feature vector is. Okay, just in a while. Okay, so that is your machine learning. Okay, so let's say for feature vector, let's say you have been given a task. Okay, you have been given a task is for this. Okay, to determine if if the image is dog or cat. Okay, and you have an image, obviously you have an image, right? You have an image. Sorry, what is just happening right now? Okay, let's actually have it white. Okay, uh, white. Okay, and now let me just, oh damn it, not like this though. Okay, I don't want this to be filled. I just want this like this. Okay, and now what if I just draw a cat over this? Okay, so I'm really not good with the like maybe like the cat could have whiskers. Okay, maybe a mouth. Okay, and eyes, right? And maybe ears like this. Okay, I really suck at drawing, like really. Okay, so this is a cat's image, assume it. Okay, this is your cat's image. So how exactly, like now I need to determine like from from artificial, like from an AI algorithm, or what we also call it a model. Okay, we will going to see what exactly the model is. Okay, we need to determine like if this image is a cat or a dog. So what we do, let's call it features. So what are your features here? Okay, your features are like ear shape, ear shape, right? Maybe eye shape, right? And maybe like weight of the cat, or and maybe whiskers, right? These are all features of a cat. Yes or no? Right? These color of eye, yeah, obviously color of eye is also there. Like okay, so these are all features of cat. And what do we call it? Like what exactly it is? It's a cat, obviously. Okay, and this cat is called a class. Like class is something that we determine with our model, like if it is a cat or if it is a dog, right? So that is why we can call it a class, or sometimes even label. Let's call it a label. Okay, so what we do here basically, okay, So we, let's call it a, like a model. Okay, and we have a pair of features and labels. Right, and these features label pair actually get into the model, and we actually train this model. I will gonna explain like what exactly the training is. Okay, and this actually spits out a trained model. Trained model. Okay, this trained model, this can run inferences. Okay, for image data. All right. Okay. Like I will gonna explain what exactly the inference mean. So let's actually take it again. Let's actually see. So we have, we have features here and we have label. What were your features? You had, eye shape, ears, those, and you had the label. Label could be your cats and dog. Okay, cat and dog, and you train a model over it, and you basically determine like if the image is of a cat or is of a dog. Okay, that is called a model training. Okay, model training, basically training your algorithm, okay, to make decision about like if it is a cat or if it is a dog. All right. Okay, and now let's actually let me again come back here. Okay, so that is what I am referring here, feature vector. Your feature vector is nothing but, vector is more of a mathematical term here. Okay, like where we determine like, like this is your vector. Like vector is, one dimensional array in Python. Okay, but right now we are not studying about vector, so I will not gonna, we'll just not gonna touch upon it either. So now let's see. Okay, so now here. Okay, so this is nothing but your model here. Okay, so what exactly the modeling is? Now you might now you might ask like what the model is. Okay, so your model. Okay, when we formulate a mathematical function, from the data. Okay, that function will be called model. Like I will just gonna explain how. Let's say you have a data, like you have a, let's say you have an xy plane here. Okay, let's say you have an xy plane here. All right, and now in this one we have like, price, not here, but the price not here. Like you have area here and you have price here. All right, and and this is something like this is your house price prediction problem, which we are going to see. Okay, so now like let's say like you have the area here around like, let's actually start it with 100 or like 50 square kilometer. Okay, not square meter, like 50 meters square. Okay, 50, I don't know the exact, like let's actually call it m. Okay, meter square. It is 100, it is 150, it is 200. Okay, it could be 250. Okay, let's see. Okay, and now based on that, like obviously the growth will be linear. What do I mean by that? Like for this one it will be, let's actually call it, 100k, let's call it 200k, let's call it 300k, something like that. Okay, now here and here, I'm just plotting out a simple, xy plot here. Okay, so for this one, what exactly the coordinates I can have here? 100 comma 100k. What do I mean by this here? What do I mean by this here is, like like what exactly 100 square meter will going to cost 100k dollars. Let's actually have it in dollars. All right, and now let's actually, let's like now let's meet these lines here. What if I do this? Okay. So what I just did, right? I just created a model based on these points. And these points are nothing but a Cartesian system's value, right? This is nothing but a coordinate value. This is nothing but a coordinate value. This is nothing but a coordinate value, right? And this is again nothing but a coordinate value. Okay, and this line can be referred as nothing but your y is equals to mx, because it is like, okay, mx plus c, obviously, because it is not passing through origin. I did not, like, I did not give here 0 comma 0. It's rather here 500 comma some value here. Let's actually have it 550k. Okay, 50k comma 50k. So it is not 0 here. Okay, so this is nothing but your modeling. Okay, modeling of price and area. Okay, and this line is nothing but your model here. Is that clear to everyone? Please let me know. Okay, so like model term, is that clear to everyone or not? All right. Right, like people usually stumble over it, like sometimes what exactly the model is in the first place, right? So that is why I'm just making it somewhat simpler. Okay, so I hope this is clear. If not, just let me know. Okay, and now let's come back here. Okay, so where exactly we can leverage this machine learning application, like machine learning applications, like where exactly we can leverage this technology, right? So the first one is the computer vision, like where my heart actually lies, right? So I just love doing analysis over videos and images, like just love it. Then we have NLP and NLU, right? So these actually goes for the text based processing. Then we have recommendation systems. Then we have image restoration, right? Image restoration, something like let's say you have a distorted image of your grandpa or maybe like your grandma, like and then you can restore those pixel values again to make it original, like to again make it back like the way it was before, and so on. Honestly, so on. Wherever the data accumulation occurs, like in a large amount, you can literally apply machine learning over it without an issue. Okay, and so these are basically deep learning. Yeah, these are actually like these are definitely for the deep learning. But the deep learning, what we do with the deep learning, we try to create analogy with your brain neurons, right? So we try to have an input layer, then we have hidden layers in it, and then we have those activation functions. Those actually works like your units or neurons. We make some computation out of it, then we have some layers, and we okay. So deep learning is all about your brain analogy, and you try to create a model or a layer or a neural network architecture, which we call, okay, with the help of that analogy. Like we will not going to get into the deep learning just yet, because it is somewhat advanced topic. Okay, and now, okay, now let's go here. So what kind of machine learning systems do you have? Like, okay, so we call it machine learning types or machine learning systems. Okay, so you have broadly three. I'm saying like broadly because we have, like, you can have multiple as well, like semi supervised, semi unsupervised is also there. But I will not gonna touch upon on on those. But right now let's actually talk about only three. Okay. So what exactly your machine learning systems are? ML systems. Okay. So sometimes what happens, like you have three machine learning systems here: supervised, okay, unsupervised, and then you have reinforcement learning. Okay, and these are all your systems actually. System, not technique but system. Just remember this. What exactly it is. Sir, can you please provide the notes? Yes, don't worry, guys. All these notes will be saved in a PDF format, and please go to that community, and you should actually get these notes for sure. If you don't have any problem with my any problems with my handwriting, so yeah, definitely I will go distribute these notes. Like pleasingly. All right, happily. All right. So yeah. So now first let's actually talk about what exactly the supervised machine learning system is. Supervised machine learning system. Okay, what exactly it is? Let's see. So when we talk about, sorry, my bad. Okay, so when we talk about now supervised, what exactly it is? So I briefly explained, that task of a classification. like not classification but determining between two images, like if the image is, of a dog or of a cat, right? So in that case, you had that funny looking cat here. Okay, I am calling it funny looking because I cannot draw a cat. It's so sad by the way, but I can't, I actually tried really hard even in my, early days, but I couldn't draw. Like I can never draw. Okay, I know, like it's a devilish cat. Let's actually call it a devilish cat. Okay, and you have a label with it. Like, which is like, you can consider this as a, like, you have a photo frame, and that photo frame has a picture of a cat, and like that has a sticker over it, like it's a cat. Okay, and in that case, like, you have features, right? Features is what? Features is what? Eye shape, eye shape, and maybe like eye color, right? Maybe whiskers, all right, and what else? Like weight, tail size, right? And what not, like what else we have here? Okay, like let's actually go with this one. So based on this, like just by looking at these features, and if I have like two animals in front of me, which is a dog or which is a cat, so like even your brain automatically going to determine, like going to process these features, and will going to tell, like, if it is a dog or if it is a cat. Yes or no? Okay, in that case, and you have a label as well. You have a label as well. This is called a label. Or you have the name of that, you have the name of that image. Okay, by default, like what exactly it is, right? So if I'm actually lifting this phone, I know this is a smartphone. If I'm lifting this book, I know this is this book, right? So I know, like, these are my features of, like, it looks white and it has a name over it, or like, and I know, like, this is a book, right? So okay, similarly we have this here. Okay, we have an image. Okay, and in that image we have like a picture of a cat, or an image of a cat, and where we can determine, like, these are your shapes and everything, eye color, eye shape, whiskers, and everything, right? So based on this, if we have features, and label pair, and label associated with it, then this type of data is called supervised data. Just remember this: supervised data. Why? Because of the label. Because we know, like, what exactly the data is saying, right? Like, let's say you have, again, another example. Let's say you have a, let's say you have a box here. Okay, in that box, if I write here apples, now I know, like, this box could be red or any color, right? And now this box has a label of apples. Okay, and it has apples, right? Again, we have some sort of supervision over our data, right? So that is why, and based on this, when we train our system, like when we train our model, sorry, okay, when we train our model based on features and label pair, that kind of learning or that kind of system is called supervised machine learning system. Okay, so what we do, basically, we provide features and label, right? Right, and we train it. We train on model, and now we know what exactly the model is, right? So I'm not tripping you over. Like, if not, just go back again. So this is your trainer model, right? We train on this model, and we create a supervised machine learning model. Supervised machine learning model. I'm just writing it in short. Supervised machine learning model. All right, that can predict. This can predict. Okay, this can predict. This can predict. Okay, this can predict what? Like, if image is dog or cat. Is it clear? Okay, all right. I hope this is clear. So this is your supervised machine learning system. So what exactly your unsupervised is? Right. So unsupervised, when we do not have a label value to it, to your data. Let's say you have a foreign box or an alienated box which you have never seen in your life before. Okay, and for that, like, how exactly I can exactly show you. Let's say, uh, just a sec. Okay. Here we have this, like you have a big frame. Just assume like we have a big frame, and like this is a photo frame or something. Okay, we have a big frame, and in that we somehow, like, scientists found, like, we have four types of creatures. Okay, let's actually, like, not like this though. Let's, okay, blue creatures, and red creatures, and no, yellow creatures. Like, let's say we have three creatures here. All right. And here, like this represents, creature value. I know this is a lame name, but creature value. And like this data is totally anonymous when it comes to label. I don't know what exactly this blue data is, like, creature value I mean by here, like, like we, let's say, like, by some chances, or fortunately Elon Musk takes us to planet Mars, and we found some creatures. And what I'm trying to do here, I'm trying to, strategizing, or, like, I'm just trying to clustering or grouping all types of those foreign creatures to us, right? So, like, let's say you found blue, maybe like deer. Okay, let's call it blue deer. I know, like, it is totally lame. Let's call it blue deer. And, let's call it, red lion. I don't know, I like if lion is red or not. Okay. And let's call it, what exactly you can call it. What is not actually yellow but is actually yellow? uh, you know yeah, okay, yellow buffalo. Okay, yellow buffalo. Right. I have never seen in my life yellow buffalo. Okay, so that is why it is a totally. These are all my, like, these are all my, like, foreign, like, alien animals to me, and we don't know the name yet. Okay, so what we can do, like, we don't have, and the data is anonymous. What do I mean by that here? Data is anonymous. Okay, data is anonymous. Right. Yeah, yellow rabbit. You can definitely go with the yellow rabbit too. All right. And now what I can do here, let's see. Like, like, it will be a fun thing. Okay. Let's actually go here. I can go here. Okay. I can, and also we have a right here. Okay. So I can, I can cluster the data. I can cluster the data. Okay, sorry. Based on similarity of each feature. Okay. Okay, I can cluster the data which is looking alike, right? Basically, what do I mean by that? Which are looking alike. Okay, so what do I mean by that? Okay, let's make sure write it here. I can cluster the data, cluster or group the data, based on, based on similar feature values. Okay, this kind of system is known as machine learning, unsupervised machine learning system. And you can also see that when you are visiting, like Amazon.com. Let me show you how. So if I go here on Amazon.in, let's actually go here. Okay, let's see. Like, I was actually, I just bought these Tug Life, like these classes. So now what will gonna happen, I don't know, like, what exactly, like, okay, this kind of data I have. And now what I can have, like here, like, let's see here. Okay, here. So this is I'm getting a cluster of similar results. Okay, this is a cluster of similar results here. Okay, cluster or group of similar results. Okay, what similar results? I just went for the tug life glasses. Okay, and then I got these. Okay, so this type of this is also called, recommendation system. Okay, recommendation system. Okay, not only this. Let's say if I go to, let's say, to here to Netflix. Let's actually go to the Netflix here. Okay, and I have, like, I have been watching these. Okay, I actually watch a lot of anime. I watch a lot of, like, sitcoms. Like, recently I'm watching How to Become a Tyrant. Honestly, I don't know why exactly I went for that, but it's quite interesting. So Right now I'm watching this, how to become a tyrant here. Okay, so I will just gonna go, I will just gonna get recommendation based on this only. Okay, so what exactly I am watching here? Okay, also for this one, okay, I watched an anime. So okay, Netflix now can determine like, okay, he might be into this stuff. So why don't I actually recommend this? So now you can see I'm getting recommendation for the Naruto, or maybe like again here is an anime. Okay, so these are the anime. Okay, again, so what we are doing here, we are basically clustering or grouping similar entities or similar feature values. That's it. So to come back here, okay, what we are trying to do when we derive, insights or observations from the from feature values only. Okay, so what do I mean by that? You have features but not labels. Just remember this. So this type of learning system is called unsupervised machine learning system. All right. Okay. Is that clear to everyone? Okay. And now let's see here. The last but not the least is your reinforcement learning. Okay. So when I talk about what exactly the reinforcement learning is, it's like training your dog. Honestly, it's nothing but you're training your dog. I will gonna explain how exactly. So let's say you have a dog. मशीन लर्निंग के लिए कौन सा सॉफ्टवेयर यूज होता है सर, प्लीज बताइए। सर मशीन लर्निंग के लिए आप एक पैकेज यूज करते हो जिसको अपन बोलते हैं sklearn, समटाइम्स फॉर द डीप लर्निंग वी यूज टेंसरफ्लो, इवन pytorch, okay, and theano is also there but it's somewhat outdated. And for the machine learning we use, okay, I just explained, I think sklearn and numpy is mostly famous for, okay, for the packages. But when it comes to theory, machine learning is nothing but your linear algebra, differential calculus, integral calculus, and matrix multiplication. It's nothing more than that. Okay. So if you have good grasp over these concepts, you can play really good in machine learning domain. Yeah, Octave is also there. Definitely, Octave is also there. So VMware is what? Like VMware is basically for your editor, right? It's simply recommending the items for or from the same cluster. Exactly, Vinay. So yeah, okay, yeah, Octave. My very first machine learning algorithm or which I wrote was on the Octave. So yeah, use Python for it. I will gonna use Python for it. So don't worry, Manodin. All right. So now let's talk about machine learning. Like in general, like reinforcement learning. What exactly it is? So your reinforcement learning is like training a dog. Honestly, like nothing but training a dog. Okay, like to put an analogy over it and make it somewhat simpler, it's nothing but training a dog. So how exactly? So let's say you have a dog here. Again, like I will just gonna suck at drawing. So let's say you have a dog here. I don't think so. Like like dogs have such like I would rather go here. Okay, and now like let's say dog. Let's search for the dog. Okay, and now we have this dog here. Open image in new tab. Right, and now let's talk about this dog. How adorable this dog is. But I really don't like dog. I'm more of a cat person. Okay, and now let's talk about this. Okay, let's consider like you have two systems for this dog. Okay, the first one is your reward system. Okay, and second one is your punish system. So let's say you have a few instructions. Let's call these instructions here. Okay, you have instructions like when you ask your or when you order your dog to play dead. Okay, and if the dog obeys, you apply this reward system. I will just gonna call it RS. Okay, I will just gonna call it RS, and I will just gonna call it PS for the punish system. Okay, okay. So if the task is done, like play dead. Okay, if the task is done and not done. Okay, and now in this case, it's a reward system, otherwise it will be punished. And for the reward, let's say like you are giving it a, like you are giving your dog a cookie, or in that punishing system, you, let's say you are giving your dog a scolding. Okay, assuming. Okay, so now let's say for the play dead, if it does it, like, okay, reward system. If it is not, okay. So based on that, what we try to do, we maximize we maximize reward system to we maximize reward system to achieve, you know sometimes this plan actually, to achieve desired behavior from our dog. Okay, so this is your, so what you are trying to do, you are trying to reinforcing that behavior which you think is correct based on maximizing the reward system. Okay, so in this case, this is your reinforcement learning, right? So in this case, this dog is nothing but your agent. Okay, and these are your, reward system and punish system is your nothing but your policy. Based on what policy you will just gonna reward your dog or not. So that is your reinforcement system, and your reinforcement learning can occur with supervised and unsupervised both. Okay, just letting you know. All right, so these are the these are your broader terms for each system. We can go with the semi supervised as well, like when we have little data or little label. Okay, I will not gonna get into it just yet. Okay, and now go here. Okay, and now here, right? Let me again open this. I don't know like where exactly we are. So, okay, so what we talked about, like what we discussed so far, like we discussed, classification. Like, so for the supervised machine learning, we have a task for the classification regression. Like, you will gonna see like, these tasks 99% of the times in your beginners, like in your beginners, phase of your machine learning. I may have not explained regression, so let me explain what exactly the regression is. Okay, I have actually, the predicting that house price. Do you remember, based on the area, that was the task of your regression, right? So that was your regression, predicting predicting house price. Okay, and predicting a class. So predicting images, dog or cat. Okay, that is your classification. All right. Sir, in recommendation system at backend, do we change the parameters or algorithm itself to get the desired behavior? It's actually a good question. Okay, so your recommendation system is based on matrix factorization, right? So you have a sparse, like it can also be achieved with the link prediction task as well, like which was developed by the Facebook, like back in 2018 or something. I don't recall. I cannot remember the exact time or date. Okay, but it can also be achieved with the link prediction task, like like when you get that notification for like, let's say you have a friend here, like for the recommendation system, you have a user 1 and user 2. Okay, and let's say you have a user 3 as well here, right here. So let's say your user 1 and user 2, you both are friends. Okay, and let's say like your user 3 is friend with user 2. And now what we can do, we can we can suggest this, suggest this link. Like this was actually primarily, it was called link prediction task. Okay, suggest this link, like if user 1 or user 3 can be friends or not. Okay, so that is also worked as a recommendation system. And for the recommendation system, the other technique which we can incorporate, like which has been incorporated so far, was your matrix factorization. Okay, so in matrix factorization, what we do, basically you have lots of data. Okay, and that, like, let's say you have user 1, user 2, user 3, let's say user n. Okay, and you can have some like some like blank values in these scenarios. Okay, so what we do, like there's a technique called MF, like matrix factorization, as I explained. So we try to fill this value with this technique. I cannot get into the details just yet, but if you really want to check this out, just type on Google matrix factorization. Okay, matrix factorization with RS here, recommendation system. Okay, all right, okay. Now come back again here. All right. So that is your, for the unsupervised machine learning systems, what exactly they are. So when we don't have a label and we want to predict a query out of a cluster segmented group, right? I explained, right? So your clustering, your anomaly detection, novelty detection, dimensionality reduction is kind of a, unsupervised machine learning system as well. We will going to see that. All right. And now, reinforcement learning, training an agent based on rewards. So learns the best strategy called policy. And we define policy in two terms here, like in two submodels. The first one was your policy for, reward based system. And for the second one was your punished based system. All right. Okay, and now how does a machine learning algorithm learns? So now it's actually quite interesting. So you take model, update the parameters. So what do I mean by the parameters here? I will gonna get into this, but we will gonna touch upon this like much in extremely good details like tomorrow's session. But now let's actually make a machine learning model in the first place. Okay, so now there are much more than this in order to make a machine learning model, but I'm just providing you a boilerplate of creating a machine learning model here. Okay, so now let's see like how exactly we can create it. So when we talk about that, the process of creating a machine learning model, so how exactly it should go. So let's say, okay, no, not like this. So okay, so now let's talk about what the hell, sorry, I should not say what the hell. Okay, so let's say you have this, I'm just you have this here. I will gonna come back to it what exactly it is. Okay, and I right now I'm talking about supervised machine learning system, supervised ML system. Let's see like what exactly we can do with this. Okay, so you have here features and labels, and we have already I have already explained what exactly the features and labels are. You train a model over it. Okay, right. And after that, like this is your train model. Let's call it your train model. Okay, and on that train model, okay, let me again redraw it here. On this train model, what we do, we pass a test data. I will gonna explain what test data is, and it makes a prediction. Let me explain what the test data is. Okay, so we train our model on training data, and this is your testing data to determine like if the prediction was right or wrong. Okay, so like I usually explain this with the help of a coaching center example, and like in your D-Day example, like it could be like let's say you are preparing for IIT JEE. Assume it, even if you are from commerce background, let's assume it like you are preparing for IIT JEE here, right? And for that examination, like in one way or the other, like you have to take some sort of coaching, like if you are not like if you are already a brightest student in your neighborhood, like you are already gifted and a prodigy, maybe from the very beginning, I humbly bow down to you. Otherwise, like you might have to take like some form of a coaching class, or some form of a help in your desired domain. Like it could be a physics, it could be a chemistry, it could be a mathematics. Okay, let's say in that, like let's say you have a coaching center here. Okay, you have a coaching center, and in that coaching center, like you what you do, like you basically consume what you consume here. This is your consumption. Okay, this is your consumption here. You consume what? The first one is maybe like mock test. Okay, second, data. What do I mean by the data here? Maybe the test series provided by your teachers, right? And maybe like like important questions, right? Such data in order to crack that exam, right? Important questions, maybe like previous questions, something like that. Okay, and what you do, third thing, what you do, basically, you give weekly tests. You give weekly tests in that coaching center. You have this mode here. Okay, I think like this mock test is nothing but your weekly test. So I will be just erasing it. Okay, and let's call it 1 and 2. Like you have only two things here. Okay, data, which is in this case your test is important questions, previous year questions, right? And in this case, like you have weekly tests. So let's say this process goes for straight 6 months. Okay, and this 6 months is your training period, right? This process is your training period, like where you are training your brain, or maybe your, like your strategies, like how to crack that exam. Okay, in your coaching center, and your coaching center is nothing but your training environment, right? Basically, you are training yourself. Okay, and now comes the D day. Now comes the, the final day, where you are going to, test whatever you have learned so far in real time. So how exactly we're gonna go with that? So let's say, like this is, like it's main JE exam center, not your coaching center, not your typical coaching center at all. Okay, so what you will be only given here? What you will be only given here? Test questions. Okay, and you have already trained your brain here in this coaching center, right? In this coaching center. So what you will gonna do? You will going to pass like all those learnings through this, coaching centers, coaching center, centers environment, learning. I will just gonna call it learning. Okay, learning, right? And in that scenario, you will gonna have some accuracy. Let's say for the 6 straight months you get, 90% on an average, like in each exam. And here, like on in the coaching center, like in the coach, like after the on the test questions, you get, let's say, like 87%. So what exactly it proves? Like whatever the material you consume at your coaching center, you basically did well in your, main exam. So like that is why what we do similar thing when we are training our models. Okay, so we train our models on our training data. Similarly, we did with our, brain on a coaching center data, and we test it like on an unseen data which your model hasn't seen so far, or never seen ever. Okay, so that is how we determine like if our model or if our machine learning algorithm which we developed is working fine or not. Okay, so that is your like training and testing example as well. So if there is any question to this as well, so please put it in your chat, like in this chat box, or like I would be glad to answer those. Okay, so now let me come back here. Okay, and now I will just going to explain a simplest example of, like, and not only not even here. Okay, so I can just go with the, like, uh, at scale learn random forest. Okay, I will gonna explain what exactly the random forest is. Sir, here main JE will be representation population, but in ML model we do training on sample, not on entire population. We develop some hypothesis. Yes, we do develop hypothesis. Okay, I'm talking about here on a superficial level. Okay, Firefox, Mozilla, definitely. Like that. In that case, your model can be biased. But my entire, goal for that was to make you understand about like why do we need training example or training environment, and why do we need testing, environment. That's it. Okay. Uh, okay, and now let's go here. Like it's extremely simple. So I'm just coming here. Like sklearn is the godfather when it comes to, developing your simple machine learning algorithms, even sometimes complex. Okay, so it's the godfather. You will never going to regret it. Like even they have provided good references and, like good documentation about like each algorithm. So just don't worry about it. Okay, and now let's actually go here. So I think they have a few examples here. I will just want to make it short and simple. That's it. Uh, okay, I don't think so. They have it short and simple. I think I have developed it like here. Okay, so I will gonna, bring it here. Okay. Mm, let me call it. I think iris. Okay, iris problem. I hope like it does have that. Hmm. Let's call it iris. Like I will gonna explain what exactly the iris is. Okay. Okay, all right. So yeah, it does. Okay, so now what I will be doing now, like we have a problem called iris data set. Let's see what exactly this iris data set is. I will gonna explain what exactly it is. Okay, so don't worry about it. uh, First, let's try to understand the business problem. And yes, 90% of your machine learning model, or maybe like more, I'm not exaggerating here, more than 95% of your machine learning models can fail if you do not understand the business problem, if you do not understand the domain problem. If that is not the case, do not go for the coding. Instead, I would highly recommend you to understand the business problem first. Okay. All right. And now let's actually try to understand the business problem, or the problem which we will going to solve with our predictive model. Okay. So like in this case, we have been given, like if I somehow, if I hide these names here, you can never tell which one is which. Like in this case, this is called a versicolor flower, this is called a setosa flower, and this is called a virginica flower. Okay, and if I hide these names, okay, like let's say if I hide these names, no one can tell, right? Like which one is which. And we have four features here. Like I explained what exactly your features are, right? So we have four features here. Like we have sepal length, sepal width, and petal length and petal width. So this is your sepal width, okay, and this is your sepal length, okay, and this is your petal width. Sorry, okay, yeah, no, this is your sepal petal length, and this is your petal width. Okay, so this is your width, okay, and this is your length, and again this is your width, and this is your length. Okay, based on these four features, I have to determine which class is which. Okay, and we can segregate these classes in versicolor, setosa, and virginica. Right. Okay. Now let's come back here. I hope the problem statement is clear to everyone. It's nothing but determining, like between three classes based on four features: sepal length, sepal width, petal length, and petal width. Okay. So now let's come back here. So I will be, so I don't have the data yet. So what you can do, like what exactly it is, first actually let me show you. Like I will gonna get into it like in much more detail in our tomorrow's session, but let me just show you what exactly it is. So this is your, a virtual environment or a cloud-based environment where you can run your, your Python script or Python code. So you will be provided a RAM here. You can see like you have RAM around like 12.69 GB, and you also have some disk space here as well, like 107, like 107 GB of space. Okay, and now right now what I'm, let me zoom in a bit. So I'm using here three libraries. Okay, right now I'm importing three libraries here, and yes, this is the prerequisite. Like if you know Python, that is totally fine. If not, please ask me questions. Okay, this is for handling the data. You can see like I have made some comments here. This is for computation. Okay, computation for the matrix multiplication and everything, and this is for plotting the data's result. Okay, and now what I just did here, I am just reading that data. So how exactly you can read the data? What you need to do here, just go here on, let's just type a Kaggle iris data set. Okay, go on to this link, iris species, and like go here on the, first you need to sign in. Just remember this. Go here, just click on this download button, right, and just download it. And what else, what you need to do, just go here and upload that data here. Okay, so you can see like you will gonna have that .csv file, and which you can upload here. And okay, so now what I am doing here, I'm just reading that .csv file, and .csv file stands for comma separated value or comma separated file. Okay, comma separated value file. So what do I mean by that? Like you have a file. Okay, like you have a file. Okay, let's assume you have a file which has abc. So now this abc is comma separated, like simple. Okay, all right, and now I am like I am printing out five values here. So you can see this is my feature 1, I am calling it f1. This is my feature 2, this is my feature 3, and this is my feature 4. And based on these four features, I need to determine the species. And we have three species here: setosa, versicolor, okay, and virginica. Okay, and now let's see how exactly I can do it. So now when I do it, like info, like I will gonna get back to it, like I will gonna explain exactly. But like we have sepal length, like each feature you have here is in the float. Like like we have two types of data types here: float and and float and int. So right now like every value is float. Like like this 1.0, 2.1, these values are called float. An object is your string object here. Just letting you know, string object here. Okay, and now Let's talk about this here. Describe, I will gonna come back to it. Describe, like I will gonna explain it tomorrow. Okay. And now, like here, what I'm doing here, this X is nothing but my features. I am just segregating my features and my label separately. So you can see I have feature one, feature two, feature three, and feature four. Right? Okay. And now when I what I'm doing now, like you can see, like my Y is Setosa Virginia versicolor. Now what I am doing, I'm training the model here. I will come back to it, but just understand this, random forest classifier as your model to determine those classes. That's it. That's all you need to know right now. Okay, I'm not gonna get into the jargon of it, but just consider this as a model to classify those species. Okay, and now when I talk about this, I have already explained why do we need training and testing set. Okay, and now what I am doing here, I'm just fitting this model. Fitting basically here, basically, training your model, training your model. And this dot fit, I think I will gonna touch upon this, like we're going to explain it in much more detail how exactly this dot fit actually works. All right. And now I train my model on based on what, like training data, like this is my training label, these are my training features. Okay. And now when we see this here, so now I'm making a prediction here, like what, like I have trained my data, I am taking a sample out of my data, like this is my sample. Okay, like the first value out of the test data here. Okay, and now I'm making a prediction here. This is my prediction. So based on that, like this is my versicolor. Okay, so this is my sepal length, sepal width, petal length, and petal width. Okay, this is my sample here, and based on that, I can determine like if it is Satosa or not. So okay, it is actually okay. This is actually not doing good. So it's basically it's actually Satosa, but my model is predicting it to be a versicolor. So we will going to improve upon it. Okay, so that is how your machine learning model actually works. Okay, so yeah, so this is it for today, guys. So if you have any questions, then please ask, and I would be glad to answer those. Okay, please ask. Now let me stop this screen sharing. Okay, yeah, that is much better. Delimiter is comma. Yeah, delimiter is comma. Any questions, guys? Please ask. Okay, I'm waiting for your questions. Wow, we still have like around 75 people. How we decide the test size? How can we save ourselves from overfitting and underfitting? That we do with the help of cross validation. Okay, and we determine like if there's a thing called imbalanced data set. All right. So what is the education, sir? I am a simple BTech graduate. Okay, from information technology. That is my education. Determining test size depends upon the volume of data you can have. Like okay, let's say you have only like 150 or 200 data points. So what you will just gonna do in that case, you can perform some sampling techniques in that case. Okay, like okay, but from which college, sir? I am graduated from Government College of Bikaner. How can we guess which regression to use? Regression is one, guys. Okay. Uh, like when you have multivariate and linear regression, of course. So multivariate when you have more than one feature, so that is called your multivariate, right? Uh, Hi sir, I need basic knowledge in ML where I can take good input. You are at a place where I'm giving you basic knowledge of machine learning. Okay, so I'm commerce, can I learn? Yeah, definitely you can learn, Sumit. Why we go for other training sampling methods if we have stratified? I just explained you might have unbalanced data set or imbalanced data set. Okay, like let's say 98, 90 and 10. Well, in that case, you can use other techniques as well, right? Like, and this imbalanced data set can be also handled by, like with other metrics as well, like precision and recall and like, those ROC and AUC curve. All right. So good night. I'm confused between ML and machine learning concept. Not available. Yeah, I will gonna. I'm using Ink to go. Can implement decision tree? I can implement decision tree. Good night, Ashish. I think we give test size and training data size. Yeah, and code itself. We give only test. Okay, suggest a good software. What kind of software do you need? I don't understand. Just use this collab notebook. Okay, I have not even touched upon any softwares yet. So machine learning complete notes are available. I will gonna provide these notes. Don't worry. Good night. Good night. Okay. We'll see you tomorrow. Okay. So please join in again, and I'll be on time this time. Sorry for that. Okay, for the last time. Okay. Okay. Good night. Good night, everyone, and see you tomorrow. Okay. Very this time, and till then, take care and bye bye. Okay. Take care. Bye. Thank you. Thank you so much for joining in. Okay. Bye.